In this video, we're going to talk about the periodic table, which contains everything that makes up the material world we know. These are the building blocks of our universe. We have metals on the left side of the periodic table and non-metals over to the right. And for the metals, the most reactive ones are going to be our alkali metals, which are group 1. Alkaline earth metals are pretty reactive. They're in group 2. Then we have our less reactive transition metals, and these are the ones you think of when we think of metals. Something metallic, something used in coins or wiring or for tools or something like that. And then after that, we have post-transition metals, which exist under a section called the metalloids, which are kind of like the transition between metals and non-metals. And then we have our non-metal elements, and then we have halogens, which are the most reactive ones, and then ones that aren't reactive at all in our noble gases. So elements all have different properties, and today I want to talk about why each element has different properties than the other elements. And it really comes down to this. It comes down to Coulomb's law. So Coulomb's law describes the strength of attraction or repulsion between charged particles. So if you have two positive charges, they repel. Two negative charges, they repel. But a positive and a negative charge will attract each other. And the stronger the magnitude of those forces or those charges, the stronger that attraction is. And the closer the distance between those two charged particles, the stronger the force. So close together, strong force. Big charges, big force. So when we look at the atoms' sizes, what we will look at is, we'll take a look at atomic radius first. We can see that the largest elements are down to the bottom left. And here's why. If we're just going down within a group, which is a vertical column on the periodic table, each row has one more energy level than the one before. So basically spacing the electrons further and further away. So more shells, the electrons get further away, so they're attracted less strongly. Then the elements get smaller as you go to the right. And that's because each element has one more proton than the element before. And the addition of that proton to the nucleus gives it a stronger effective nuclear charge, which describes how strongly a nucleus attracts an outer electron. So the effective nuclear charge is going to increase as you go across a row on the periodic table. And you might be thinking to yourself, yeah, but you're adding an electron too. True, but those electrons are either going to be far away from each other or have opposite spins, which helps minimize repulsion. So the elements are going to get smaller as you go to the right, and they get smaller as you go up into the top right. So then, what makes something metallic? Metals like to lose electrons. And the easier it is for them to do that, the more reactive they are. So the property that we use to determine that is called ionization energy. And if we look at this, it's very much the opposite of what we just saw. The metals down here have very low ionization energies. It's the energy required to remove its electrons. So it's easy to remove electrons from a large element and very hard to remove electrons from a small element. That's because the nucleus, again, the closer the two charged particles are, the more strongly they're held. If you have a small atom, the electron's very close to the nucleus, and they're hard to remove. So the most reactive metals are going to be down and to the left because they're big, the electrons are easy to remove. The most reactive non-metals are going to be the ones that are best at gaining electrons, because remember from last unit, they need to gain electrons to complete their outer shell. So the term property we're using to describe that strength when attracting electrons in a bond is going to be called electronegativity. And you can see that fluorine, can't help itself, it's so attractive, has the highest value, and that the metals over here have the lowest values. So here you have the most reactive metals, here you have the most reactive nonmetals. These are the best at losing an electron, these are the best at gaining an electron. It all has to do with the size of the elements. Notice the noble gases, aside from these two exceptions, pretend those don't exist, don't have values here. And that's because they have complete outer shells and they don't form bonds, so they can't have really a strength of attraction when competing over electrons in a bond. Anyway, so those are the three properties I wanted to talk about today. Atomic radius, ionization energy, and electronegativity. Thank you.